also a panel about bridging HPC and quantum computing. It's not an easy topic. It's different type of machines. I think we can start with Stefan. Can you tell us about GenC and how you integrate quantum computers, this new type of machines? I believe that you have just launched a QPU Pascal last week, and that the QPU Candela should arrive soon. Why is this choice, and how do you do that?
Okay, so thank you very much for this invitation. So yes, I'm working at GenC. GenC is a French HPC agency with the mission to provide access for free to researchers to supercomputers and now QPU. It has been said by Loïc this morning, we're involved inside HQI, so the French hybrid HPC quantum initiative with INRIA and CA, to purchase QPU, to make them available like we do for classical supercomputers, and also to promote them and to support the community for engaging and going to this hybrid HPC and quantum. So we made the choice to hybridize HPC and quantum. It was the same choice we did 20 years ago with GPUs at the beginning. Okay, it was less difficult, but we are on the same way because we think that the future of HPC is to be hybridized with quantum. And we think that before the end of the decade, we think that several use cases could benefit from this acceleration by using QPU as an accelerator. So why we purchase QPU, and we purchase French and European QPU, because we think that there are 8 architectures available in the world, and France and Europe is mastering 6 of the 8. So it's something we cannot miss. So even if the QPU is still a bit noisy for the moment, it's already possible to use them, to assess them. So we make available emulators and real physical QPU. So you talk about Pascal, the 100 qubit Pascal QPU will be available at TGCC. So coupled with a supercomputer called Joliot-Curie in 2 weeks. We have already remote access to the cloud of Candela, so you can use with us and with Candela remotely for the month, but physically soon a 12 qubit photonic device. And at the end of the year, we are going to install a real Candela supercomputer in our facilities at CA, and it will be like Pascal, accessible for free for assessing this potential of QPU for academia and industry.
Thank you. Jean, what are the technical challenges to implement a QPU in this type of infrastructure like GenC?
Oh, there are challenges everywhere. So we can say that there are challenges on the hardware side and on the software side. For the hardware side, one of the main challenges for the hosting entity, the GenC in that case, is to kind of accommodate with the kind of exotic requirement that this computer comes with. So unconventional cooling system, absence of electromagnetic field, where we are in data center where there is electromagnetic field everywhere, or absence of vibration. So it's things that are quite hard, and I'm very admiring what the work that GenC has been doing for the computer they have purchased. And on our side, the challenge is to try to alleviate this problem. So first, to make something that looks like a computer, to be able to deliver a box that's not a room, that's not a laboratory lab, that is just a computer, it could be a computer. And this is a huge technological challenge to be able to do that. And for that, we need on our side, so we are quite lucky that we don't have so much exotic requirement. Our system doesn't have any problem with cooling or vibration, but still we need to build a computer. We need to build and integrate, and we need to follow the path of 50 years of the HPC community, and to be able to put in a rack a lot of stuff that are a bit scientific, but stuff that are also very conventional. So for instance, powering, how do we power, how do we cool this system? And for that, on our side, we look closely at, for instance, Open Computing Project, which is kind of giving the guidelines on how to build a computer. So there is this association that provides a way to make a powering unit, to make a way to cool. So we are trying to follow the path of all these people. On the software side, also there is a lot of challenge too. So the idea is to be able to operate a computer that is kind of still experimental stage, without having anybody on site. So we need to have the ability to have this computer stable all the time. So this is a huge challenge. And we need to also to have this computer to talk with what is around, because the computer by itself, as Stéphane was saying, is not just is just a part of the HPC as an accelerator. So this is another challenge that we have.
Okay, and as a hardware and software provider, how did Candela envision the role of hybrid system? What are the main use cases that you think this architecture could be benefits from?
So I think that the work we are doing with HPC is critical. We need to be hybrid. A quantum computer, so there is this idea that quantum computer is kind of the ultimate computer. And I like to say a quantum computer is just a quantum accelerator. And that has to integrate with the full stack of what is around CPU, GPU, and even other type of acceleration. So it has to fit, it has to be hybrid. So now it's easy to say and how we can use that. And so the applications on which we are focusing a lot these days, and for which I think that in the very near future we'll see some real applications, are applications that are naturally hybrid, like quantum machine learning, where naturally we look at CPU that run the program, we look at GPU that makes the hard work, and we are trying to fit in QPU that can make some acceleration or some annotation, quantum annotation in the full process. So I think this will be one of the first applications that will fit.
Thank you. Maybe Stéphane, you want?
Yeah, no, in our side, yes, we identify also quantum chemistry, because quantum chemistry in general is very close, the physics is very close to quantum computers. So we think that it will be possible to program quantum chemistry. It's important for us because in our machine, quantum chemistry with a big C, it's 1/3 of the cycles we are allocating from traditional CPU. So it could be for biology, for medicine, for material science, for health. So if we can produce a quantum advantage and offload this production to quantum accelerators, it will be something very important for the community. Then we can of course think about optimization problems. So we run since 5 years with the Paris region and with the support of Lab Quantique and Teratech, a specific program called PAC Quantique, in which we enroll close to 15 use cases already from big companies, SMEs. And we saw that, yes, we start to see the potential of some algorithm. When we are going to have the machine, that will be ready, and we could demonstrate something interesting in that field. Yeah. But quantum machine learning is also something very promising. The main problem is the weakness of the link between the CPU, the GPU, and the QPU for the moment. But this will improve in the future.
Okay, it's really interesting. Another question for you, Stéphane, and maybe Jean after. How do you program on HPC plus a QPU hybrid system? It's not easy to connect sometimes to a HPC for programmers. I imagine it's different than using emulators and to connect directly to the QPU.
In fact, we have different paths. So the strategy of integration between HPC and quantum for us rely on the use on a high-level environment called Captiva from Eviden, in which we couple the QPU to the supercomputer. So this is for allocating at the same time the CPU and the QPU. And also we have a kind of high-level programming language allowing you to program in a gate-based way, in a portable way, your application. Of course, this is not exclusive, so we have also some specific software stack provided by Candela with Perceval, or from Pascal with Pulsar, etc., etc. So this allows you to have the single stack of the vendor. This allows you also to program at a low level. If you are a Jedi of programming, you can go at the lowest level and to program at the pulse level. This is very good for this kind of people. But if we want really to engage people with safety and we want to engage not being Jedi for everyone, we provide this high-level view. So this is very important. So of course, everything is not set. We have Captiva, we have the Pulsar and Perceval. We are missing some intermediate libraries also. For example, in HPC, we are using a lot of numerical libraries, a lot of packages. This is missing for the moment. So this is really something which is need to be developed. We also need to progress on the different kind of algorithm available. So of course we are playing with 7 to 8 algorithms for the moment, which is not enough if you compare it to HPC. So we can progress on that side. And then you talk about emulators, of course. Even if we have 2 QPU, in the future 4, the resource is so scarce that we cannot afford everyone to access to a QPU. So emulators will play a crucial role for validating before running on the physical QPU, as well as benchmarking and optimizing the result and validating the result of the simulation. So we have this approach, and we are sharing this approach with also our colleagues in Europe, developing the software stack. The holy grail for us will be to have a full European software stack. It's on progress, it's not done, but we are working on that.
John, do you want to comment?
Yes, I really like the JDI image, and I really think at the same time that we don't want people to be JDI. So I like to be JDI. I like to be. I used to program an assembly language 30 years ago, and I think now the challenge is to hide the quantum complexity, everything that you are saying, and for that we need to integrate in scientific library that exists today. So people, for instance, I give an example, that want to make some operation matrix. They don't multiply by matrix by themselves. They use CUDA or they use Eigen, which is a library that are meant for that. We need to be part of this. So and our role today is to try to hide all the complexity and to find the point where the quantum can bring some value into this chain. When we'll have done that, then the end user will not even know that he's using quantum. He will just do some scientific computing, and some primitive will be offloaded to quantum, which bring the question of scarcity that Stefan is mentioning. But this is our role to hide that. But the end level, at the end, the user should not see that. And we need to do our best. And there is so much work on algorithm and software development to do to reach that point.
Stefan, what is the vision of Europe and Euro HPC regarding hybrid computing?
In fact, what is good is that the vision we have in France is also shared in Europe. So you mentioned Euro HPC. So Euro HPC is a joint enterprise between 34 countries and the European Commission towards the establishment of a pan-European HPC, AI, and quantum infrastructure. They are also funding the R&D, etc. So it's a big agency for HPC in general. So what is good is that they have the same feeling like us. They consider the fact that we have a lot of opportunities in Europe for quantum computing. So they are funding different QPUs across Europe. So for example, the QPU we bought with the Candela QPU has been acquired jointly by GenC and by Euro HPC. They are doing the same in Germany, in Spain, in Italy, in Finland, in Poland. Perhaps I'm missing some of them. So the goal is really to deploy quantum everywhere. European technologies first. Of course, we could work with others, but we need first to serve ourselves. And then to establish this joint software stack for allowing this coupling between Euro HPC and national computers with QPUs in the future. And they are also organizing training, they are organizing the ecosystem, so it's really nice. And they are also now trying to liaise with, for example, the quantum flagship and all the different various initiatives, because in Europe it's very siloed. So the goal of the European Commission now is to break this silo and to have really a smooth integration between the R&D and, for example, Euro HPC at the production side.
Thank you. Maybe in one sentence, what will make hybrid HPC plus quantum computing a real game changer in the next 5 years? Jean?
Can be a long sentence? No, I will just say what I say, is that it will be a game changer when it will be integrated in scientific libraries where we won't even know that we are using quantum. We will know, but we won't even need to have any knowledge on how it is done behind the scene.
Stefan?
So I fully agree, so I will say something different. It will be a success if we're able also to provide use cases and to make the proof, to stay humble, to not promise the moon tomorrow. But we know that before the end of the decade, there could be some quantum advantages. Let us make them happening in France and in Europe. Yeah.
Thank you, both of you. I think it's clear that the path to hybrid quantum HPC is already unfolding. And I hope to see you the next years to see the progress. Thank you very much.
Thank you very much.